Okay, so continuing with our notes. Now, this is more likely, okay? This is much more likely to happen when we're dealing with means, okay? When we're dealing with means, we're going to use what's called a t-distribution. Ready? There's an acronym that's used to remember this, and it's called ZAP the PACS. Z's are for proportions, and T is for X bars. So almost always when we're dealing with sample means, okay, you're going to deal with what's called T. Now your critical T formula is the same, it shows it right here. T equals X bar minus your mean, divided by your sample, standard deviation, divided by the square root of n. It has the t-distribution with degrees of freedom, okay, df equals n minus 1. So we'll just talk about this for a little bit, okay? So this is when we don't know the population standard deviation. And that's probably more common in real life situations, okay? So this is important, put this in your notes. This is the Z distribution, okay? That's the Z in pink, okay? The T distribution does this. So the brown, that's your T distribution, okay? And if you notice, they're both normal-ish, okay? The pink one is normal. The brown one follows a normal pattern, but there's more room in the tails. The reason there's more room in the tails is we don't know the standard deviation. We have to leave a little bit of extra room for variability, okay? Now, one thing that will happen is, I'm going to draw another one of these, okay? I'm going to make this my Z distribution, okay? And then we're going to call the brown, so that's going to be my Z. There's just not enough time that day, guys. That's my Z distribution, okay? Now the brown one is going to be a T distribution with n equal to, we'll say it's equal to 15, okay? And then I'm going to do another one, another distribution, and this one is going to be another T distribution. This one is a T distribution with n equal to 28. What do you notice about the blue distribution, the T distribution, when the n gets bigger? It becomes more normal. It becomes more like a normal distribution, okay? So as T goes up, our data becomes more and more normal. It becomes normalish. If your T is small, you're going to have a lot of room in the tails. As T gets bigger, your graph becomes more and more normal. Notice it's not quite touching the pink, but it's getting close. It's getting close, okay? So this statistic will have approximately a T n sub n minus 1 distribution as long as the sampling distribution is close to normal. Degrees of freedom, this idea of degrees of freedom, we're not going to get into it too much. I certainly don't have time for that. But what you have to know when we're doing these, and you type it in your calculator, which I'll show you in a minute, you have to subtract 1 from your sample size, and that's going to be your what's called degrees of freedom, okay? And as your degrees of freedom go up, your graph becomes more normal. So density curves, the T distribution, are similar to the standard normal curve. The spread of the T distribution is a bit greater. Degrees of freedom increase, the T density curve approaches the normal curve more closely. So, we get to this next question. Suppose you wanted to construct a 90% confidence interval for the mean of a normal population based on an SRS of size 10. What critical value T should you use? Okay, so we have to find a critical t. Okay, find a critical t for this. So we're going to go to our calculator. Okay, go to our calculator. Where's my calculator? Here it is. Go to the calculator. And we're going to turn it on. Now, when we did critical z, we hit second dister, and we went to inverse norm. Okay? Now this calculator doesn't have it, so I got to find another calculator. You guys should all have up-to-date calculators. It shouldn't be an issue for you. So I think I made sure everyone had one with this button on it. So again, we do second dister. Okay, here's your inverse norm, but guess what? We're doing it for t. So we're going to go inverse t. Okay, inverse t. INVT. And then it says area and degrees of freedom. So what did it say? It said a 90% confidence interval. So if it's a 90% confidence interval, okay, a 90% confidence interval, you take that 90%, you divide by 2, okay, because it's going to be split into two tails. So for an area, I'm going to put either 0.95 or 0.05. And then degrees of freedom, my n is 10, so my degrees of freedom is 9. Let's find a critical t. So 0.95, enter, degrees of freedom is 9. Enter, 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 and I get 1.833. And that is my critical t. So I want you guys to take a minute to go back to the Check Your Understanding on page 501. Okay? Actually, forget that. Let's just do the current Check Your Understanding. So the CYU on page 507. CYU, page 507. Do that now. Okay, so if you're not done, just pause the video so we can do this. We have a 98, 90, and a 95. A 98, a 90, and a 95. And the first one has 22, 10, and 7. 22, 10, and 7, that's our N. This is our CI. And then we got to have a critical T. Okay, so let's do it. Let's do it. Let's go to the calculator. Let's hit our second dister. Let's go down to inverse T. It's a 98% confidence interval. So in the two tails, we're going to have a 1% in each tail. So my degrees of freedom, if this is 22, my degrees of freedom is going to be 21. I should get, or does it tell me degrees of freedom? What does it say? Nope, it says 10 observations. So it's negative 2.52, or 2.52, I should say. 2.52. The next one, there's 10%. Take that percent, split it in half. It's 5%. Second dister. inverse T, 0.95, 10 observations, I'm going to make that 9 for degrees of freedom. And that's going to be 1.833, I think we just did one like that. And then this one's at 95%, so that means we have 2.5% in the tails. Second dister, inverse T, 0.025, degrees of freedom 6. I get 2.45, 2.45. And those are my 3 critical T's. All right, here we go. Constructing a confidence interval for U. Here we go. We're getting a little bit longer here. We're going to push through. 229. Only 10 minutes into this video. We got this, man. We got it. We got it. So, here is your standard error. Again, standard error. Okay? Margin of error is everything after the plus or minus. So for these, it's plus or minus a critical T, standard deviation divided by the square root of n. This is your margin of error. This is your standard error. You gotta know it. They're gonna ask you those questions, know the difference. Okay? A one sample T interval. That's what we're doing, a one sample T. Choose and SRS of size n. Here it is. Here's your formula. Okay? Use it if your population distribution is normal or the sample size is greater or equal to 30. If that's not true, you've got to make a graph. Make a graph and show that there's no severe skew or outliers. Okay? Population is at least 10 times the sample. That's your 10% condition. That's not changing. Okay? Random, normal, independent. Here we go. Okay? Random. Data comes from a random sample. Very important. That's for the center. That's make sure that you have an unbiased estimator, that your X bar is legit. Okay? Normal. The population has a normal distribution or the sample size is large, greater than or equal to 30. Independent. Individual observations are independent. Sample size is no more than 10% of the population. Here we go. Can you spare a square? As part of their final project in AP Statistics, Christina and Rachel randomly selected 18 rolls of a generic brand of toilet paper to measure how well this brand could absorb water. To do this, they poured a quarter cup of water onto a hard surface and counted how many squares it took to completely absorb the water. Here are the results from their 18 rolls. Then I think the directions say we want some sort of confidence interval. So let me see if I can find out which one we want to do. Yeah. We want to estimate, construct and interpret a 99% confidence interval. Okay? Let's do that. Construct and interpret I forgot what I said already, 99% confidence interval. Those are kind of pointless, but we'll do what they tell us. 99% confidence interval. All right, here we go. The four-step process. The beauty of the four-step process. State, I always tell you, it's restate. Restate the problem. We want to construct. We want to construct a 99% confidence interval for the true mean number of what? Squares to absorb a quarter cup of water. The true mean number of squares it takes to absorb a quarter cup of water. Now, if you think that you can go on and do this without my help, awesome. Pause the video, give it a shot, see how close you get. That'd be awesome. I'd love it. I would love it. Okay? Plan. So now we've got to talk about our plan. Okay? So what are we doing? Name our test. This is huge. You have to name the test. It's huge. I don't know why, but it is. We are going to do a 1 sample T interval. Okay? A 1 sample T interval. That's what we're going to do. And now we're going to do our 3 conditions. Our random, our normal, and our independent. Okay? Random. Let's see. Randomly selected. It states the what? Data was randomly selected. Normal. N needs to be greater than or equal to 30, but guess what? It's not. N equals 18. So now what we have to do is we have to go to our calculators, okay? We have to go to our calculators and we have to make a graph and show there's no severe skew or outliers. So I go to my calculators. Okay, where am I? Okay, I go to my calculator and I hit my stat button and I hit my edit button and I'm going to clear out L1. I'm going to make it clear there. Clear. I'm going to add these in. 29, 20, 25, 29, 21, 24. I hope you're doing this with me. 27, 25, 24, 29, 24, 27, 28, 21, 25, 26, 22, and 23. Now, I go to my stat plot. I turn my first plot on. And what do I want to do? I want to do a graph. You can do a bunch of different ones. I'm going to pick the graph that shows outliers. Zoom 9. Zoom fit. There's my graph. There is my graph. A thing of beauty. A thing of beauty. Now, I should make a number line underneath it, right? And let's see what our values are. If I hit my trace button, I know that my minimum is at 20, and I go to 23, 25, 27, and 29. So I might go 20, 25, 30, okay? And I have a dash at 20, I have a dash at 23, I have a dash at 25, I have a dash at 27, and another one at 29, and I draw it. And I say, since my graph has no outliers or severe skew. You see the actual terminology that they want there. We can use the normal approximation. We can use the normal approximation. Okay? Pretty cool. Random, normal, independent. Independent. Ready? What do we want to say for independent? We're going to say that 18 rolls are less than or equal to 180 rolls. So we're going to say that 18 rolls is less than or equal to 10% of the population of TP rolls. Okay, we're talking about a sample that's less than or equal to 10% of the population. So now we want to do the do step. Okay, we want to do the do step. I'm going to have to work into my board here. You guys are patient with me here. So we're going to have